the NIST network that we have, which dealt with the digits 0, 1, all the way up to 9. If we were dealing with a shallow network, we could still use a shallow network to do that. So shallow network means that our output here, we are going to have, because we want to classify into 10 digits, 0 up to 9, we are going to have 10 neurons here. So this neuron N1 here will be the class for 0 digit. And then this neuron 2 here, N2 here will be the class for 1 digit, all the way up to neuron 10. And then the 10 will be used for 9 digit. So this is the shallow neural network. Now, so the output layer, where our output is going to come from, we have already defined them by the number of classes we want to have, which is 10 classes. And each class will contain a unique digit. So that is the first point, our output. Now we need to have our input features. So our input features, we call this one S1, S2, all the way up to SK, where these are the number of features that we are applying as input to the network. So as we said, and you are familiar with already, this input here, the neurons don't perform any computation. The neurons don't perform any computation. Please, somebody. Kevin, please, can you mute? So the neurons, so the only neurons that will perform any computation are the hidden layer, the first hidden layer, and then the output layer. This layer 1 here and layer 2 here, they are going to perform, their neurons are going to perform computation. Now, so when we are designing a multi-layer neural network for any application, we need to identify how many layers are we interested in developing. Is it 5? Is it 20? This is a shallow network, multi-layer network. Now, then the next one is the input that we have. We have already indicated the number of classes we want to have, which is 10 classes. So the number of input layer, what are the features that we are using? What features are we using for our work? You remember early stages, we were dealing with maybe sorting out students in the school. And we said we are going to use number of features, maybe age of a student. We are using maybe height of a student, we are using maybe weight of a student. We come up with so many elements that we want to use. So these elements here, age, height, weight, course code, on and on, year of admission, all those things are going to be our input. So those are the S1, S2, S3, on and on and on. That describes, those are inputs that describe the object that we are going to use. So we may have 1,000 students, and each student is an object. And this object, we may have to indicate what are the features we want to use to describe the object. They are going to be in our input layer. And each input layer will be connected to a neuron. So all this input one here, X1, will be connected to all the neurons in each layer, the forward layer. S2 will also be connected to this. Now, so this neuron first layer here is our computation layer. So this neuron is the one that is going to do the input times the weight plus the bias. So this neuron will be biased. Each neuron here will be biased, apart from the input layer, because they are only placeholders. They only receive input information. So they don't perform computation. And so this is what we are going to have, summation, and then we perform our activation on that. And that will give us the output that is going to come from this neuron towards the output layer neuron. So this is what we dealt with in the previous segment. Now, how many neurons we are deploying here will be a design issue. There is no rule that says that when you have input this, your layer first should be this number of. There's no rule like that. What they are, the rules that we have are indicative rule or suggestive rule that, okay, if you have 50 inputs here, when you start with just one neuron in this layer, it wastes a lot of time. Right. So we say, okay, if you have a certain number, maybe you can start with an indication, maybe 50% of that or 30% of that. So it's a design issue that we have to go through the processes, do learning and on and on and on to establish what will be the best number of neurons we have to deploy here. That will give us the best results. Now, coming back to the input, you dealt with, Ken explained something to you. Now we are dealing with the NIST. So it's an image. So this image, we look at the image as a two-dimensional data. So this is, let's say, digit for 8. This has 28 by 28. Now, so if we were to use this image as an object, as our input, what would be our S1, S2, S3 all the way out? What would be that number? It's a two-dimensional, but this input layer here is not a two-dimensional input. It's a one-dimensional input. So how do we deal with it? So one way to deal with it is, since this doesn't support a two-dimensional, but 1 by X dimensional data, then we have to now bring this data into 1 by S dimensional data. So if we are dealing with this, the image data that we have, it contains what we call integer data. And that integer data, they have been, so this is how we see it. It's a grid So our first data, for example, will be this. We can start with this. So when we take this row, we take this column, then we can have the value. The first value will be here, second value will be here, third value will be here, fourth value will be here, fifth value will be here, on and on and on. But because we have to use the image information comes in 3 primary colors: red, green, and then blue, means that we are going to have one by data for red, one by data for green, and then one by data for blue. That's what we are going to have. So each value here, we have to now subject this value into what we call integer values. So typically for this data, all image data, we use what we call 8 bits to represent that data. So if we are going to use 8 bits to represent that data, then what we see is that for each data, we can then, for each data, 8 bits, we have to now put this 8 bit on an integer scale. So we say that that value will start from 0 all the way up to 2 to the power 8 minus 1. So 2 to the power 8 is 256. Minus 1 will give us 255. So we are starting with, so the value will be integer level. So we will not have decimal. It's going to be 0, 1, 2, all the way up to, this is 251, all the way up to 255. So when we are dealing with red, green, and blue, we are going to have a shade of red, the green, red one, we are going to have various shades of red from here all the way up to the maximum shade of red. So there are different shades of red. When we are dealing with the green, the same thing, green, the lowest shade of green, all the way to the maximum shade of green. And then the blue, the same thing, various shades of. Now, so when we are dealing with the colors, then these are the 3 primary colors. And when we mix those 3 primary colors, we can get different shades of colors. So this is what last weekend was trying to explain to you. Now, so it means that if you pick column 1, we are going to have various values that will be dependent on that. Then we pick column 2, we are also going to have different values that will be representing each of the points, which we call the pixels. So once we have this information there, if we choose only the red color, then we are going to have 25, whatever value we have here. If it's 28, 28 by 28 for only the red element. If we choose the green, also that. And then we have what we call the monochrome, or we call it, the technical word, we say grayscale. Grayscale is what we know in our normal parlance as black and white. So that black and white, we have the lowest level will be black and the highest level is white. That if we are dealing with black and white color, then the lowest will be 0, which will be black, darkest shade of black, and then the highest will be white, the highest shade of white. That will be very, very light spot. That is what we'll see here. So again, but in terms of values, they are going to be from 0 all the way up to that value. Now, so when we say that we are dealing with the NIST value, and we say that this is the value for, let's say, the digit 8, that digit 8, we are going to have, and it's 28 by 28, I'm going to have 28 rows and 28 columns. But because, as I said, this is not a 2 matrix dimension, it means we have to find a way to make this a 1-dimensional data. And reshaping of the data so that it will give us 1 by 28 times 28. S1 all the way up to this value here is going to be X 784. That is for the image. I'm assuming that I'm using black and white, monochrome, or grayscale. So I'm going to have this. And each of these element, they are going to be the intensity values, each ranging from 0. So we can have different values that we'll be having here. Now, so let's assume that now this is only 28 by 28. Assuming the image size is 256 by 256 or 300 by 400, that means our S input is going to be, if it is 300 by 400, our S input is going to be S1, S2, all the way 300 by 400. That gives me 120,000. So I'm going to have S1, S2, all the way up to S 120,000. So that is going to be my input that I'm going to use to perform this by computation. Bigger, then we are going to have a problem because our input that we are going to apply will be very huge. This is where, after dealing with this, we'll come to what we call the convolutional neural network. So that, which is also a deep network, but it has different forms of layers, and each forms of layers will do certain operation that will help us to reduce the image size to a very minimal number that we can easily manage. Uh, 10 by 10, so that our 100 or whatever number minimum possible we can reduce it to. So the image data that we have, this is where we have that one now. And then we can have, so based on the 28 the way up to S748 as input, and each input will be all the way fair is going to perform summation of all the inputs times their corresponding weight S J Y J, where my J is 7, 8, 4. So I'll perform this summation, and that summation, I call it maybe Z1. Perform, if I want the output of this neuron here, then I perform what I call my activation function of Z1. So if I'm using a logistic sigmoid activation function here for this layer, I'm using logistic function, then it means that for this function, I will have it as 1 over 1 plus E minus Z1. My Z1 is equal to, based on these summations that I have here, and the values S1, S2, they are all going to be their actual intensity values. Then you see that the maximum we can see is 255. So this 255 is, when we are going to compute this 255, we are going to multiply by the weight. Let's assume that the weight is, maybe we said 0.1. So we are going to have 25.5. So we are going to have this times 25.5. That's what we are going to evaluate. It's very large. So one of the ways, which I think last week Ken mentioned to you, is that when we have this data, one of the ways we can do is to normalize this data that we have with the maximum value. So if the maximum possible value we can have is 255 in the data, then we normalize. So we call this one our SY. And then we normalize that by the maximum, which is 255. So that our values here, the maximum we can have is 1, and the minimum we can have is 0. Otherwise, the value will be distributed between 0 and then 1. So we can have 0.1 up to 1.0. Because the intensity values we have here, there is no negative value here. It means that we are not going to have any negative value as a Z, unless our what do we call it? Our weight function, we are having our weight distribution from minus 1.0 up to plus. But once we sigmoid function, and we have dealt with this already, where we can plot this function, we can plot it. Now, if Z is equal to 0, any number raised to the power 0 is equal to what? 1. So we are going to have 1 over 1 plus 1, which is half. So it means that when Z is equal to 0 here, we can have a value of what? 0.5. And then when Z is very large, we are going to have 1 over, all this will be approaching 0. So we have 1 over 1, that will give us 1. And that is for large values of Z. So it means that it will, at a certain point, it's not going to start from here, but it's going to, from here, it will be saturating to 1. Now, when you have this also, again, it will also go all the way to negative. So it means that when we have negative values, these are negative values of Z, the value will be saturating from 0 up to 1. So this is our logistic sigmoid. All the output we'll be getting from it will be saturating from +1 all the way up to 0, with the middle value at 0 being equal to 5, 0.5, half. So this is what we are talking about here now. So so all the neurons here will be performing that same operation. They will all perform what we call logistic sigmoid function, every one of them. And their corresponding output will all be connected to this. Now, what we said is that we are going to have what we call only 10 classes. And we have already labeled that the first neuron here, we said it should be assigned to 0 digit. The second neuron should be assigned to 1 digit. The third neuron assigned to 2 digits, on and on. So we have already defined which of these neurons is going to perform that operation for us. So Mariama mentioned that, okay, the last layer, which is the output layer, she mentioned what we call softmax. She mentioned what we call softmax. So the softmax helps us to perform a probability of these output. So when we take a sample number 1, if we take an image number 1 with 28 by 28, we don't know what it is, but just one image. It could be digit 5, it could be digit 2, it could be digit 0. We take that image. Now we have S1 all the way up to S784. We go through the process, and then if we are using the softmax is going to give us what we call a probability distribution of all the output of each of these segments, each of these neurons, after we have provided this digit. And the one that has the highest probability, then to say that, but all this will scale up to 100%. So the one that will have the highest probability, it will say that this digit that I provided, the probability that it is digit number 3 is high because that has the highest probability. So this is what the concept of what you are trying to do. But that is if we are using a shallow neural network model. So for the digital NIST data, we have 60,000 training samples. A mixture of all of them, 60,000 of them. So we'll pick sample 1, sample 2, sample 3, all the way up to sample 60,000. Find out which of the bin, which class that bin based on the softmax. So network. Then it also has another test. So this is for training. It also has 10,000 samples for testing. So after we have provided our training 60,000, it will give us this. Don't forget that the weight that we are using for the connection, initial weight, they are all randomly selected weights or randomly generated weights. And we have already talked about when we say training. The training is now if we put sample number 1 here, and that training sample number 1 we expect it to be, we know because we have labeled it. So once we are putting that sample number 1, we know that that sample number 1 has a digit number 6 on it. So when we put that sample number 1 in it, and it gave us that the sample rather belongs to digit number 3, we know that it is wrong because what is on the digit is number 6. So it means that this is an error, and the network will have to adjust the network way to give it a better training or to make it learn better. So after we are done with this, now we do all for the 60,000, and then we can say that now let's evaluate the performance of our training. Then we saw that the performance of our training is, let's say, 35% accuracy. 35% accuracy means that out of the 60,000, if we are looking at each of the assignments that have been made in the output, only 35% is accurate. Then we say, no. It is not good enough. So what then do? We come back and say, okay, now let's increase the neurons. We have to look at what are the possible things we can do. As for the output, it is fixed because that's the classes we have. As for the input also, it is fixed because we are picking it from the image, the number of digits on it. So it's also fixed. So the other thing that we have that we can change is we can change the number of neurons in this layer. So if we start with, let's say, 5 neurons in this layer, then we say, okay, now let's try maybe 7 neurons. Or see, if you want to do it sequentially, let's try 6 neurons and then see what will happen. And we will compare the performance of the 6 neurons, and then we see, has it improved? If not, we say, okay, now let's move to 7 neurons. So we keep going up until we see what will the best, if as we are going up, the performance accuracy is increasing, then we keep going until we get to a point where we get to the maximum accuracy possible with the number of neurons. That is one thing we can do. Now, the second thing we can also do is we can also change the learning rate, the rate at which we are learning. Another thing we can also do is we can also change the number of epochs. That is the number of training cycles, how many training cycles we want to do. We can also change that. So these are all possible things we can change in an attempt to make sure that we improve upon what? Our accuracy. We can even decide to say that instead of using logistic sigmoid, we are changing to hyperbolic time function. We can do that and then change. So we are trying to find out what will be the best model, that's the neural network architecture, in terms of number of neurons and all those things that will give us the best accuracy. That is the training accuracy. After we are okay with that, now we can say, okay, now let's now use the testing data. This training accuracy, this testing is not part of it. The network has the model that we have here. After we have trained it, then we get a model. Otherwise, we have an algorithm. So after we've gotten our model, then we say, okay, now the model has not seen any of the samples here. So we are now going to use our samples here to test the network and see what performance we can get. Of course, we have already taken, Ken has taken you through what we call the performance metrics that we measure. So that is about the shallow network, where our network is fixed, 3-layer network only. Now, when we are dealing with deep neural network, then we are talking about having more. After we have, let's say, the 3, and then we think that we are still not getting a good performance, then we have another option. The other option is, can we then introduce another layer here? Can we introduce a second hidden layer here? Now we have moved from a shallow to a deep, but lower deep. So this layer that we introduce, then we have to now provide some neurons on this layer. So let's say we ended on this layer here with, let's say, 20 neurons here, or even 50 neurons here, and we are still not getting good performance. So, okay, now let me introduce another layer here so that I will improve upon my learning experience. Then I say, okay, now, while this one is 50, let me start with maybe 5 of the neurons here. And then this neuron, I was okay, this neuron is also performing maybe logistic sigmoid again, so that then I keep building up again. So now I have 2 hidden layers, this and that. Then I go through the cycle and see whether the performance will be introducing the second layer, a second neuron, try a third hidden layer. Then it means I'm trying to move what? Into a much deeper network model or deeper network architecture. And this is what leads us to what we call dense or deep neural network. If still for the image operation, it's still for the image operation. So what you dealt with, this is the concept. I'm not going to the details of the learning, but this is what you went through. So in your operation, what you did was you define your input, you did your reshape and everything to get 1 by n elements, which is going to serve as your input function here, input neurons here. And then if you move away from the shallow to deeper, then we say, okay. But normally the way we work, if you were doing a project, the way we work with, we will work sequentially to be seeing what will be the best network architecture that we need to have. So what you may do is that Ken will say that, okay, maybe let's start with maybe 3, or let's start with 5 network architecture. So in that case, our first one is the input, first hidden layer, second hidden layer, third hidden layer, and then we have our output layer. So that gives us 5 network architecture. Or he can say, okay, so 5 network architecture, then we can say, okay, now, how many neurons do we want to have over here? So each of them, we have to define the number of neurons we want to have here. And then here also, here also. As for the output, it is fixed because we are dealing with classification. So if you are dealing with classification, you have to define the number of classes. In the case of the NIST, that's digital data, we are going to have 10 output classes here. And this deep network, we can also use it to perform regression tasks where we want to have a continuous output. In that case, we can have only 1 neuron here where it's going to perform our operation for us. Or we may want to have 2 neurons depending on what we are trying to monitor. Maybe we want to monitor temperature and then pressure. It has something to do with classification. We are monitoring temperature and pressure at the same time. In that case, we can have 2. And the value we are going to have is going to be continuous data. So we can use the same network for regression tasks, and we can also use it for classification tasks. In this context, we are looking at classification tasks. So we focus on classification tasks. So having explained this concept now let's now move on now to our Python development platform, where now hand over to Ken to pick it up from there. So Ken, I'm going off the screen now, and then we can now continue But let me ask, does anybody have any questions so far up to this point? Does anybody have any questions so far up to this point? Okay. So if no questions, so now we move on now to the Python development framework. So I'll go off the screen. Now, Ken, can you please share your screen?
Yes, I'll do that in just a minute.
Master's level course in the neural networks. This is what I take them through. So for you, because it's a training program, we are not interested in taking you through the detailed mathematical framework that will go through all these processes. So we only take you through just a basic concept like this and then show you now how we can deploy that. So all those who are taking, I'm teaching, it's a first semester course. So a number of, I have about 4, so 5 master students. They are taking, so we are going through the detailed processes involved here.
All right. Good evening, everyone. Okay, so as usual, we are going to continue from where we left off the last time. And then I have a very simple exercise for everyone. Okay. So based on the material I shared for the GitHub repo, which I believe you all have downloaded, there is included in that file is this article on deep neural network. And I think this is a good read, at least for some understanding. So the title of the paper is Methods for Interpreting and Understanding Deep Neural Networks. So it basically gives you the general overview, some of the things we've spoken about, right from some definitions, some concepts, and then almost everything we've said. Okay. So once maybe you have time, you do that. There are some other files in here. This is already included in the document. So there is this particular one. I was just trying my hands on some few things. Now this is the one called the test model. Okay, the notebook test model. So this one. So I would want you to open it, and then you follow along just as I'm about to. And I'm going to tell you exactly what this code entails. So remember, last Friday, we developed a deep neural network for handwritten digits image classification. And Dr. Mills has just run us through some of the things that we spoke about last Friday. So my goal actually is, okay, so now that we've built some model to classify images, handwritten digits, what about, okay, that model is there, and inside of, once again, the material, you see that I have this saved model.h5. So the model that we built, it is saved over here as saved model.h5. And that's what I've imported in here to do some classification. So over here, what we did last year, and this is what I want you to do. So the code is already here. All that you need to do is to take just maybe a cardboard or a white paper. Make sure the background is black. White. Okay. And then you use preferably a blue pen or maybe a marker to write maybe some numbers. And what this code is going to do is you need to, if you're running this for the first time, you need to import a library called OpenCV. So this is the name of it. Let me see. Download OpenCV. Okay. So I think the name of the good. So you do pip install OpenCV -Python. So let me just copy this and put it in the chat so that those of you who want to do that right away can proceed on that. Okay. So once you have this installed, then you can basically run it, because the rest of the libraries, I believe you have them. Time is not a library you need. It is one of the inbuilt modules in here in Python, so you don't need it. Now, what basically this code is basically trying to do is, with the OpenCV, we can use this to activate the camera on your laptop if you have a webcam to actually capture images. So what we did last year was we write the number on a sheet of paper, preferably a plain sheet, A4 sheet. We write the number boldly written, and then we run this code. It will activate the camera, and then we show the number to the camera so that at least it captures it. And once that capturing is done, it is saved in here. Okay, so you see I have captured images, and we have digits image dot JPEG as we have over here. And then once that is done, we import matplotlib, and then we also import pill from image. And then we go through the process of the image that we downloaded or we captured. Basically, we open it up over here so that we have some kind of an image, okay, data. So this one is what I was just working with. This one just captured my face, but then I want you to write a number. So what I want you to do is, if I run it this way, once again, clearly you could see that it has my face captured over here. And what I want you to do is to take a sheet of paper like I'm doing, and don't do it the way I'm doing it, at least do it quite big, okay? So I'm going to write a number, let's say 4. I'm using a red pen to write 4, and then I'll show it to my screen. Okay, and you want it to capture as much as I have over here so that the image classifier, when extracting this, okay, it is able to extract. But then if you have your face showing and other images showing, it is definitely going to distract the image extraction. So you just have to do something like this. Like I said, a very thick one. And what you do in order to capture this is to press on the kill key. So when you press on kill key, it captures it and it gives you a timer. And when it's 1 to 0, it captures. So this image or that image has been captured. And if you want to close this, when you click on this, it doesn't close. So you just have to press the escape key to close that window. Now, once you have this, it is actually going to be saved in this captured images. And this is what we have with the image we just dealt with, okay? Now, this image, well, let's try and see if it gives us something good over here. But then ordinarily you want the writing to be very thick, because it goes through some processing, it takes away the color, gets some monochrome image, and it kind of reduces the quality of the image. So we just want to be minded about that. So when we run this, and then we run it this way, and run this, we have this gray image, and then when I run it, this is what I have. So I have this 4 showing up over here. So it has taken away the color. And then when I do im.show, plt.show, we have it this way. Okay, if you remember when we were previewing the numbers we saw that it looked a little bit like this in some way, somehow. So we had a lambda function over here to remember, we are saying that if the numbers inside of that big matrix, if it is less than, if it is 0, okay, or if it is less than 0, or in between this, sorry, if it is less than, if x is, okay, so we are saying that x is 0 if it is less than 100, and then it is 1 if it is 255, as we have over here. So let me also run this, and then you clearly see that the image is what we have over here, and I mean, clearly you could see that a lot of the things have been taken away, okay? But then let's try and see if we actually get what we want. So eventually this is what we have. This is supposed to be the 4. So that's why I said you need to write very thick. And then we run it this way, and this is what we get. So now over here, we go through this, and then clearly you could see that the number is not showing. And if you are to get the shape, everything looks good. And then when I run the final image, we get something like this. So this is the matrix representation of the number we just captured. And then we load that saved model into a new variable called my model. So we are saying keras.models.load model, and we just type in the name of that model.h5. So we run this, and then what we do over here is, yes, we want to do a prediction. So the model that we have loaded, my model.predicts, and we pass in that final image. But over here, we do a reshaping based on how we want things to show up over here. So the prediction is complete. Now let's do a preview of this and see how things will look like if indeed we are going to get the prediction as 4. So we get some value over here, or some prediction over here. And let's see. So over here, we have the probability distribution, and this is 0. Okay. This is 1. This is 2. This is 3. And then this is 4. So 4 is about to the power -6, which is very low. Okay. I was thinking maybe this one will give about a 50%. So it is telling us that there's a 50% chance that the number we just showed is 3. Okay. Based on the indexing and the way Python works. So this is 0, 1, 2, 3. And then this is our 4. And this is 5. 5 is about a 42%. As you can see, this is to the power -1. And it goes on and on and on with the other ones. Now, let's try and make things work a little bit. So what I'm going to do is I'm going to capture the image again. And basically, the new one is going to override the old one if we do that. And let me just show you this. So one of the things I want you to pay attention to is this part. Okay, so I think in the original code, if you download it currently, it does not take care of this reshape. So kindly check on that. I think last year, before I uploaded it, there was this mistake. So I corrected it and didn't do the updates. So let me let me write down the 4 again and make sure that it is very deep and thick. And I expect you to at least practice with some few numbers and see how things will go. Okay, so I've made things look a little bit thicker, and I think this is much better than previous. So let me put this, okay, let me just do it this way. Okay, so I'm going to do the kill to capture the image. Okay, so that image is captured. And then let's proceed to seeing what we want to see. So let's load this. And then now we have a much thicker image. Let's run this. Okay, this is much better. At least we can clearly see the 4. And then it doesn't look bad here as well. Okay, so I believe this one This is a final image, and the final image is looking a little bit blurred, but at least we get the market showing up over here. Okay, so now let's run this through, and then let's do the final prediction to check if indeed we are able to get something meaningful over here. So over here, we see that 0 is about this percentage, then 2, then we have 3, and then we have 4. So unfortunately, 3 is about 99%, as we can see over here. And then 4 is about the percentage we see over here, which is a little bit, I mean, very low, given how big the percentage we have for 3. But try using the marker, a very thicker writing, and maybe it will work. Let me try for the last time. Let me use a number, let's say 7. So I'm trying to make it a little bit thick in terms of the width of the number. Okay. So let me run this again. Okay, so this is the number I have for 7. Let me take my hand off. Okay, so 7. Oh. Okay, let me do a control kill to capture this image. Okay, so 7 is captured, but let me also do some manual modification over here to make sure that the way things are captured. So let me do some manual resizing, sorry. So that we concentrate on where the image is actually located. So I have this concentration. So I have this 7. So this is what we are going to work with. So let's run these ones and see. Okay, so we have our 7 showing up this way. And then this is how it looks. Definitely there are some white reflections. So we get that over here. Okay, and now let's see. So our prediction tells us that, okay, so this is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Now 7 is about to the power -4. So I think the highest we see over here is the 8, which is about 48%. And then this is about 31%. And yeah, those are the bigger values in terms of the percentage distribution. And these ones are quite small. All right. But then please try get a very good pen. I mean, preferably black. And then you are going to see that it is going to work. Now, the whole point is this is going to work because, yes, the MNIST data set is there, and we took that data set. We had no hand in, or we had no bias towards how the handwritten digits were written. But then we've been able to develop a model, and based on the efficacy of the model, we can make prediction with our own new data. That's the whole concept about machine learning and how amazing some of these things can get, because we interact with AI all the time. We didn't build it with anything, but once we give it data, and based on the learning experience, it is able to generate some new information for us. And basically, that's what you want. Now, so that's an exercise. You have the code, so kindly look at that. Now, I'll briefly concentrate on today is because eventually we are going to come back to convolutional neural network, and images are going to come back again, and we are going to work with more images. But then briefly, let's look at this. Okay, the web apps with TensorFlow. Now, web ML overview, creating web applications for ML and stuff like that. Now, some of you, I believe, already know how to work with some web development. So I think the knowledge area gap is you trying to integrate a machine learning model that you have saved into some mobile or some web application. And it is the same thing or the same concepts or principles when it comes to mobile or even any other application you can ever think of. And we can, look at other ones like even desktop applications and stuff like that. But for today, what I'm going to do is this is a very short one. Even on my YouTube channel, I have some videos you can actually spend time and go through. So those ones are actually going to guide you. So today is just going to be some introduction, because really we cannot cover everything with mobile development or web development and stuff like that. That's a complete course, probably a 3 months or 4 months course on its own. Now, what we are going to do is we are going to rely on a Python library called Streamlit. So clearly, when you do a Google search on Streamlit, it just tells you that, well, Streamlit is an open source Python framework for data scientists and AI ML engineers to deliver interactive data apps. So that looks interesting. So you click on it, and I'm going to share the link with you in the chat so that those of you who are curious, at least what Streamlit does for you is it gives you something to work with very quickly, okay, at least with the interface and some few things. And in just a matter of seconds, at least you have an application and we are good to go. So when you go through this, it just walks you through some beautiful things you can do in Streamlit. And we are going to see a very simple example that I have to show. Okay, so let me just clear this. I was working on some example. These are some few things that we have over here. st dot error, st dot. Okay, right. Okay, so there's a clean slate, okay, of some application. So this is some new.py. Let me rename this to something better. So let's call this web app.py. So this is basically a Python file. And in order to download Streamlit, let me close this. In order to download Streamlit, I think the command is pip install Streamlit. Okay, so when you do pip install Streamlit, it will have it downloaded, and then you can start using the library. So I'm going to just walk you through, and we are going to build a model. We have some models already there, so we are just going to import one over here and then work with it basically. So what I'm going to do is I have let's just have an overview of this whole library and how things work out over here. So I'm going to say import Streamlit as st, like you see in most places. And now if I'm to do st dot, for instance, write, and then inside of this passing a string, okay, and let me call this web application. Now if I save this, okay, and I'll come inside of the terminal and do Streamlit run, and the name of the Python file web app.py. When I go through this way, you see that automatically it has opened up this in localhost, okay, and the port is 808501, and that's what we have over here, okay. So web app, exactly what we had written over here. And I'm just going to show you. So basically, after everything is said and done, you can actually click on deploy, and you can just deploy this in a matter of seconds, okay? Whether on Docker or Kubernetes or any of the cloud services. And it says you can deploy unlimited applications for free. So at least this is something you can use to at least test, write your program, make sure everything is running at the back end, and probably want people to interact with it. So you can do a quick demo of deployment, and then we are good to go. So let me just walk you through with something interesting over here. Now, what I want to have is, if I'm to say st dot, for instance, title, and now passing what I have as the something like simple web app. So the simple web app is going to be the title. So if I come back and do a refresh, we have the simple web app as the title, and then we have the previous one we have over here. Okay. So what I want to do, and this is what we want to do now, at the end of the day, based on how machine learning systems work, it's always expect some input, then some prediction will be made. Okay. So let's see how we can actually design and put an input over here. And it is very simple. I can do st, or let me just come back here and say that this app takes 2 inputs. All right. So I'll come back and I'll do st dot, I think, text inputs. So most of the text widgets you ever use in maybe other areas, you can draw inspiration from that and work with some over here. So st dot text input, and then once again, IntelliSense is going to help us. So it expects a label. We can pass in value, some parameters to set some restrictions on some few things over here. So I'm just going to say, let's say enter first number, something like this. And then let me duplicate this, do a Control-C and a Control-V over here, and I'll do enter second number. Now, what I want you to have in mind is, at the end of the day, we are going to do the one at least we did with, how do you call it? The iris data set. Okay, so at least we are going to have an input field for iris settles, the petal length cm, petal width cm, sepal length cm, and then we are going to input the value. And then when we click on, for instance, maybe a button called predict, those values are going to be taken, and then some computation will be done basically for us. All right, so that's the whole concept of whatever thing we want to do. So now if I come in here, based on what you've done so far, and I do a refresh, we get exactly that. So you see that we have enter first number. That's the text I had over there. And then enter second number. And then I can type in some number over here. And then I can type in maybe another number over here. Now what you want is, for instance, a button that will pick these two values and then do some computation for us. That's basically what we want to do. Just a minute. A number is calling me and it is disturbing me. So just a moment, I'll join you. Okay, so sorry for the interruption. So that's basically what you want. Now, what I want to do is basically have these as variables and have some placeholders for them. So let's say number one is going to be equal to this, and then number 2 is going to be equal to this. So you have this, and then so far so good. Nothing changes, okay? The input fields are still there, but then now when we see, we can have those values in those variables. And now what I want to do is want to have a variable called result. So results is going to be equal to, and then I'm going to do a typecast over here, because ordinarily the value of this text input is going to be a string. So we want to do a typecasting into a float. It can be an int or any other data type that you want. Okay, but basically the float is okay. So I'd want to do this plus another typecasting, and this time around we pass in number 2. Okay, so now we want to have a button. So I'm going to say if if st dot a button, and then we want a label over here as add. Okay, if this is the case, what I want you to do is to now do for instance st dot write, and then I can put in a formatted string over here like we saw earlier on with some of the things that we did, and then pass in results. So I can say sum is equal to this. So up until then, I mean, without informing you that this is some Streamlit web application that we are building, at least these ones, it is quite similar to using the input, how do you call it, method, or the input function in Python to accept, okay, and then save it in a variable called number. Do same over here, and then we do this, and we are adding an add button over here. And if this add button is activated, what we want to do is to, whatever results that we get over here, we print it out inside of the web application. And we are getting, okay, it says couldn't convert string to floats. Okay, so floats number 1, floats number 2. It says it couldn't convert string to floats. Okay, so I think basically what we need is I don't know why, but then if we don't do the concatenate, the typecasting, it is going to end up doing a concatenation. So this is what I mean. Okay, so now let's save this and come back here and see how things will work. So if I do 12, and if I do another 12, and then we get 1 2 1 2, but we expect a 24. That's basically what I want us to work our way through. And what we can do to solve this is to I don't know why this is happening, but okay, let me try and do a concatenation into let's do an int over here and see. Int here and see. Okay, that's also giving us the same problem. Okay, let me do the concatenation somewhere. I don't know if you remember when we were using the input function, we could do something like this. I don't know if this is going to be permissible over here. So let's try this and see. And then let's do a refresh. Okay. It is not permitting that. Okay, I don't know. I think maybe I'm not using the right, how do you call it, widget over here. I think maybe I'm not using the right widget over here. But basically you get the point, okay? That whatever thing we do just writing some basic code that we already know, or at least we've written something similar in the past, we're able to build this simple web application. So having that in mind and trying to do this. Okay, so now let's do some few things over here, and we can do a Control-C, Control-V of all these ones. Okay, and then I can do enter sepal length. So I can do enter sepal length. Then I can do enter sepal width. Then I can do enter petal length. And then petal width. Okay, so this calculation is not what we need. Now we need that machine learning model behind the scene to now make this work, because you are going to input those values in here and you are going to present some kind of a result to the user. So maybe a 2.4, a 1.3, 2.4, 5 point whatever, like we saw. Okay, but then this time around we've been able to provide that interactive web interface for our users to interact with the system. And then let me do change this one to predict over here. All right, so this one looks good. So now let's see some of the models that we worked with earlier on. Please, who has a model from the for instance, the one of the how do you call it, one of the models we built earlier on for that, or maybe we can actually do that quickly if we have time. So let me do this. So I'm going to say from SK, so import from sklearn dot, from sklearn import data sets this way. Okay, so data is going to be equal to data sets dot load underscore iris this way, and this is data sets. Okay, so data, okay, dot load, call it this way. Okay, so data is going to be equal to this, and then if I do a preview of data, have it this way. So the x, or the input side of data, is going to be this, and the output, so x is going to be equal to data, and then we do a slicing of data to get our x, and then the y is going to be equal to data, and then if you remember very well, we have targets over there, so we get our y this way. So now let's quickly build them, and let's just build maybe a random forest classifier of some sort. So I'm going to say from sklearn dot I think random forest is in trees or ensemble. Who can remember that? So let's say import. Okay. Okay, so all right, somebody has, okay, it is in ensemble. Okay, so ensemble, import import, this is random forest classifier, I believe. Okay, so we have it. So now the model is going to be equal to this. We instantiate it this way. At least we are using the default parameters. And for now, let's just feed everything inside of this. Okay, So we are not going to do X train, Y train, and all those things. So now let's do model.fit, and then let's pass in X and Y, and then we are good to go. So now if I'm to do model.predict, and then pass in some values, let's see the first value you have, are you expecting a 0 of some sort? So the first value we have this, so Control C, then we pass in this model.predict. Okay, we get a 0 over here. Let's try for maybe another random one, maybe the last one. In any case, this model is really going to be almost perfect because it is the same data we use. Okay, but you get the point. At least we've gone through this, and you can actually take time to build that model and then work with it. So now what I want to do is we can now save this model. So I'm going to say I think this one we can import Pickle. I don't know if you have worked with Pickle before. There's another library. You can just do an installation of this, do pip install Pickle, and you are good to go. So now let's look at this. Let's say how to save a random forest classifier model using Pickle. Okay, so we get some information over. Let's quickly go to Stack Overflow. We are definitely going to get some help over there, as it is one of the go-to places for developers. So we get this. Okay, so this one gave us some parameters. Then we come to the point where, okay, so import Pickle, and then I can simply do pickle.dump. Okay, so this is what I want. Sorry. Okay, so now let's do pickle.dump. And then the name of the model we have is model, not RF, as they had it. And I think we are okay over here. No, I think the name is, the name we want to save it is also very important. So they use as F, okay, as a file, but then they give a path over here, and to path, no, we don't want this one. We just want, okay, this one also uses joblib, okay, which is equally a good option. So let me see. Okay, so now let's use joblib because this one is pretty much straightforward. So let's come back here, and then I'll do the imports of joblib. I think I have it installed on my system. Okay, and then joblib.dump, we want to have the model and want to save it as okay, the name over here is not bad, or let's call it rf model.joblib. So when I run this is saved inside of the directory. So if I'm to come back here and then go into that folder, we have this rf model.joblib over here. So we can load this back, or I can actually copy this. So let me do a Control-C over here and bring this back to the application I'm working with. I have a folder called sites. This is where we have the web app. So I'll load this one over here. So now we have this loaded over here. When we come to inside of VS Code, we have this showing up over here. So it is this that we are going to load into this, and we are going to accept the inputs to now make this work. But before we even make this work, we need to now import this joblib model over here. So if we go back to some of the things we see over here, if you are loading it, we just have to call it this way. So we just import joblib inside of the application, and then we use joblib.load. When we are saving it is .dump method, and then the name that we want to have, and the name of the model. And then when you are loading it, it is this way. So over here, I'm going to say import joblib this way, and then maybe write at the very top the name. Remember, we changed the name to rf underscore model, so that's what I need to change over here. So I need to change rf underscore model dot joblib. Okay, so now that we have loaded this, I think let's save this as model as we have always done. Okay, so now if I save this way, the model is saved inside of this, and then let's come back here and do a refresh. If you don't have anything popping up as an error, then we are good to go. Okay, so the model is now saved in there. Now this is what I want to show you. So you see what we have over here with this model. If I'm to work with this model, I can do some predictions. Okay, so if I'm to come in here and, for instance, do let me just come in here first. Okay, so if the predict model, button is pressed, what I want to do is I want to now do model dot predict and then pass in some values. So for now, let me just pass in some arbitrary values. Okay, let me pass in some of the values we saw over here, and then later we are going to make it dynamic basically. So Control C this way, and then we pass this over here. So we are doing a prediction, and now let's save this as prediction is equal to this. And now I want to do st dot write, and then I want to write the predictions that I have over here. Okay, so the point is, without even inputting any value, if I click on this predict button, it is going to pick up the model I just loaded up over here and going to predict based on the values I've inputted or I've hard coded over here. All right. So now if I'm to come back here and do a refresh, and we don't seem to have any problem. So now when I click on predict, we have the value 0 showing up over here. That's what we expect. Okay. If for some reason we go back and for instance pick maybe the last one is going to give us a 2. Okay, so let's go to the last inputs we have over here. So let's pick these values, Control C, and then we come back over here and put these values in here. We expect to see a 2. So now let's come back and do a refresh over here. And now let's just click on this and we get a 2. Now this 1 and 2, once again, is something that somebody just looking at this is really not going to make sense, okay? Because what exactly is 1, what exactly is 2, and stuff like that. So you can actually modify our code to rather make it make sense, okay? So now this is what I want to do. Now instead of just doing the prediction, I can say that if the predicted value, okay, if it is equal to 0, then there's a reason for that. So that one is going to be st.write, and I would want to write, let's say, Iris Setusa. I don't know if that's the one, okay. And then I'll do elif if the prediction is equal to 1, then st dot write, and this is Iris versicolor. I don't know if the spelling is correct, but then we will check. Else it is Iris Setusa or Virginica. Okay. Else it is st dot Iris. St dot write, and then I put in Iris virginica. Okay, I'll check what 1 actually means and 2 actually means and stuff like that. So that's what we see over here. So now when I come back here and do a refresh and now do the prediction, we don't get to see the 0, 1, 2 and stuff like that. We get to see something that will actually make sense to the user who is interacting with the system. All right, so we get that part. Now the other part that we need to work on is now inputting the values over here and then clicking on predict, and those values are not going to be hard coded like we have over here, but then it's going to pick up from the sorry, not number 1, number 2 as we have over here. So let me just change this to something like sepal length. Okay, so SL, and then SW sepal width, and then PL petal length, and then PW petal width. So these ones are inconsequential of whatever thing you want to do. But then let me find a solution to why we are getting what we are getting. So what I want to do is do st dot. Okay, let me just do a print of the data type of p sepal length, sepal width, petal length, and then petal width. Okay, so let me just do a printing, whichever one that comes up. We are going to see what we need to do in terms of changing of the type. So let me redo a refresh, and let me do a 0 over here, a 1, a 20, and a 22. When I do a prediction, okay, it says whatever takes 0 arguments or 3 arguments. Okay, which one is that? This one. Oh, okay. Okay, let me just. Okay. We are not just printing, but then the type. So the type just takes in 1 argument. Okay, so let me just print one of it. Okay, at least 1 is going to give us all, so it doesn't really matter. So let me do a 0 over here, or let me do a 3, 3, 3, 3. Okay, so now let's see what is printed out. So it is telling us that it is a strange. Okay, it is a strange, and if it is a strange, then why can't I do the typecasting? That's the question I'm asking. So you can actually go and ask Google and see if we can get some help to actually fix this. Okay, so let's see. Once again, changing str in what's the name of the method precisely? That's a text input in Streamlit. Okay, so changing str in text input in Streamlit to, for instance, a float. Okay, it says take float input with number input. Okay, so there's a number input in Streamlit that will explicitly help us achieve that. Okay, so this is from the Streamlit discourse, and okay, so now let's do number input and see how this one will help us. So I'm going to say number inputs for the first one, number inputs for the second one, and it makes sense, okay, because text input is going to be strange, number input is definitely going to be whatever thing we want. Okay, so now let me do the data type. Okay, the printing of, let me do the printing of the data type of just one of the variables at least. SL will do for us. So I'll do a control C of this, a control V, and then a control V of this as well. So if I come back here and do a refresh, and then, okay, so clearly you can see that the number input has made the widget change over here. So let's say I type in 4, 4, 4, 4, and then click on predict. Okay, this one is inconsequential. We just want to see, now we see that we have a string and a float. Okay, where from that string? Are we typing anything? Let me see. How many prints do we have over here? Control F. We have just 3 prints, and that's exactly what we wanted. Okay. All right. So now let's just make sure it works. We can go back to the first one. Okay. And let me just, for instance, do this. And now let me just do something like result is going to be equal to SL plus SW plus PL plus PW. Okay, let's just do something like this. And now let's do st.write. This is just for debugging purposes. And now let's do results. Okay, so at least we are going to input some numbers, and then we want to make sure that at least the adding now works. So now that we have this, let's come back here. And now let's type in 4. Let's do another 5 over here. Let's do a 6. And then let's do a 4. So I was expecting a 6. Okay, so this one is 10 and then 9. So we expected 19. So now when I run this, okay, we are getting 19. So at least the arithmetic operation is now working. We are not just getting strange concatenation showing up over here. So this is what we were after. So now that we know that this is working, now we can rely on, let me uncomment what I have over here. We can now get rid of this because we are not going to add those ones, and also get rid of this as well. So what I'm going to do is I'm not going to just pick up the values, okay? That's going to be, and let me come back here with regards to the way the data is structured, in the sense that the original data as we have over here, the order in which the things are appearing. So the first class is Setosa, that's 0. Second class is Versicolor, and the last class is Virginica, and that's what I wanted to make sure. So first class, if it is 0, it is Iris Setosa. If it is 1, it is Iris Versicolor. I think the spelling over here, Versicolor. Okay. So Control C and a Control V over here. And then the last one we see is Virginica for, okay. All right, so those ones are the first things I want to check. Now, the next thing I want to check is the order. You see, our user is not going to know what to type in first, okay? So we should kind of structure things in a way that will make sense so that the model will make good prediction. So now let's look at this. The numbers we see over here have been structured in that way, okay? That maybe this is sepal length, sepal width, petal length, so we need to also make sure that though that order is actually maintained. And the order we have is okay, so let's go and look at something on the description, because So data and then description. Let's rather print this out. I know I'm going very fast, but then these are things we've covered over and over again. So you know some of the things I'm doing. So I think the first one is sepal length. The second one is sepal width, petal length, and petal width. I think that's the order we used over here. So sepal length is first, sepal width is second, petal length, petal width. All right, so I think the order is okay. And then what we now have to do is to now come back here. Once we've accepted those inputs, what we need is the sepal length, sepal width, petal length, and then the petal width. Those ones, okay? And then, so remember, those inputs are going to be inputted by the user, and it will be accepted with the number inputs, okay, inside of these variables. And then when we click on the predict button, the model.predict, as we've already seen, is going to pick these and put it in this array. And then if the predicted value is 0, there's something we do behind the scene so that the user will not just see 0, 1, because that will not make sense to the user. So if the predicted value is 0, then what is actually supposed to show is iris setosa. If that predicted value is 1, what is actually supposed to show is iris versicolor. And then if it is 2, but then in this case, there are only 3 possibilities, so we are just using else over here. It is not going to predict any value other than these 2 or these 3 that we have. So now let's finally test our web app to see if everything works. Okay, so now let's work with some values that will make us test the system proper. So let's go with as usual, the first one, which we expect, the iris setosa, which is the first class. So the first one is, help me remember this. So 5.1, 3.5, 1.4, 0.2. So let me come back here. The first one is 5.1. Then the second one is, the second one is 3.5. So let me bring this closer. The second one is 3.5. The third one is 1.0, 1.4 and 0.2. 1.4 and then a 0.2. So now when I click on predict, we get a iris setosa over here. That model prediction has been done behind the scene, because over here, especially at this moment, we are not doing the hard coding, okay? We are actually picking the values and putting it inside of this predict function or method. For that model we saved and brought over here, we loaded it through joblib, okay? The name of the model. Now, the whole catch here is, in order for this to work, the model should be in the same directory as the application, okay? So you see that the application is inside of the same directory. If for some reason we have, let's say, a folder called ML, okay, and I put this in here, the directory has changed, so definitely it's going to affect this. And clearly, if I do, we are going to get some errors if you try predicting. Okay, it doesn't even show, because it says that it is looking for the rf_model.joblib, and it's not seeing it. So it says there's no file or directory as what you have over here. Now, if you have something like this, it's very simple. You just have to indicate it over here. So ml/. So basically, you are trying to tell your system that, okay, this rf_model.joblib, it is inside of this ML folder as we currently have it this way. So now that I've done it this way, if I do a refresh of it, what is happening? Okay, let me stop the app and run it again. Maybe it is a little bit confused over here. So let me just, okay, so I've stopped it, and then Streamlit run webapp.py. Let's run this and see how it goes. Okay, it is still not No, I've done the directory change. Model.load. Okay, I think I didn't save it, so Control S. Okay, I didn't save it, so I believe this time around it should work. All right, so everything is working out over here, and we can do some of these things. So at least from now till Friday is long enough. You can spend time, pick one of the models that you built, save it, okay, and do a deployment. And there are lots of things you can actually do with Streamlit, okay. So I would urge you to actually go through it and see how people have built some interesting stuff with Streamlit, and not just things for this. You could see some data visualization and other things you can do, and you can really do some good stuff very quickly, and you are good to go. All right, I think our time is up. Are there any questions? Okay, please, are there any questions? Okay, so in the absence of questions, I think we can end here for today. The video is going to be made available. Kindly spend time, go over it, and I think you'll be fine. And try as much as you can to also practice on your own. It's very simple to build some of these things. And also, I'll share the link with you on my YouTube channel where I use how do you call it, a different library, okay, Django, to build another one. That one is from scratch. You do a lot of hard work yourself, but I think this one will get you going quickly. All right, so we'll meet God willing on Friday. Okay, bye-bye.